Have you ever been on a phone call and realized it's brought your entire world to a stop? But then you can fire off 100 WhatsApp messages and not even break your stride? Well, that exact feeling, that's probably the best way to understand a super important concept in software today, blocking versus non-blocking I/O. So let's dive in and use this analogy to really get it.
So let's really lean into this idea. A phone call versus a WhatsApp message. Yeah, they're both ways to communicate, obviously, but the key difference, the thing that matters for us, is all about how you wait. Or maybe more importantly, how you don't have to.
All right, first up, let's talk about that good old-fashioned phone call. We've all been there, right? And it is the perfect stand-in for the traditional blocking way of getting things done. I mean, think about it. The second you make that call and somebody picks up, you're locked in. You can't just wander off and start making dinner. Your attention is totally captured. If they put you on hold, guess what? You're still stuck. You're just waiting. Your line is completely tied up. And this is a perfect picture of what we call blocking I/O. In the software world, there's this thing called a thread of execution. Just think of it as a worker. And that worker is you on the phone. When it makes a request, like asking a database for some information, it just stops. It waits. It literally can't do anything else until it gets a response. The whole operation is blocked. Okay, and here's where it gets really interesting and kind of problematic. In a simple blocking system, every single user request gets its own personal thread. So if that thread is waiting on a slow database, it's just sitting there, burning up memory and doing absolutely nothing productive. So as more people use your app, you need more threads, which eats up more and more memory. And before you know it, the whole system just grinds to a halt. But what if there was a smarter way to do this? Well, there is. And that brings us to the other side of our analogy, the quick, easy, non-blocking message. Now, just picture sending a message on WhatsApp, you type it, you hit send, and then what happens? Nothing. You're totally free. You just put your phone away and get right back to what you were doing. You're not sitting there staring at the screen, waiting for a reply. You'll just get a little notification later, whenever it comes. And that is the whole idea behind non-blocking I/O. The thread, our little worker, kicks off a task, but instead of waiting, it immediately moves on to the next job. It basically tells the system, hey, go get this for me, and just, ping me when you're done. It doesn't wait, it delegates. So the key takeaway here is that there's zero wasted time. A request comes in, it gets logged, and boom, that thread is immediately free to go help another user. Then, when the data for that first request is finally ready, the system sends a notification and a free thread swoops in to finish the job. It is just so much more efficient. So let's put these side by side because this really gets to the heart of the matter. It all comes down to how these two models use your system's workers, those threads. It's really a tale of two different philosophies, waiting around versus actually working. And wow, the difference is huge. In the blocking model, you could have hundreds of threads just sitting around twiddling their thumbs waiting for something to happen. Your expensive CPU is just being wasted. But in the non-blocking model, those threads are always busy. A very small number of threads can juggle thousands of requests at once, which means you're getting way more bang for your buck from your CPU. Seriously, if you remember just one thing from all this, let it be this right here. Blocking is a passive system. It's all about waiting. Non-blocking, which we often call reactive, is an active system. It's all about reacting to events as they happen. So you're probably wondering, how does all this non-blocking magic actually work? Well, the secret sauce is a really clever pattern known as the event loop. The absolute best way to picture the event loop is to think of a super efficient manager at a call center. Now, this manager doesn't take any calls themselves. No way. Instead, their job is to flawlessly coordinate a small team of agents to handle a massive flood of incoming calls. And this manager's process is crystal clear. First, they grab a new request. Step 2, they attach a little sticky note to it. That's the callback, which just has instructions on what to do when this is done. Third, they delegate the actual long, slow work to someone else. And finally, they only circle back when a result is ready. No time is wasted. But there is one golden rule, and you cannot break it. You can't give that manager a task that forces them to wait. That would be like the manager getting stuck in a long, boring phone call themselves. The entire call center, the whole system, would just grind to a halt. Everything in this world has to be non-blocking to keep that loop spinning fast. Okay, so we get how it works, but why does it matter so much? Well, this is where it all pays off, when your application needs to grow and handle way more users. It all comes down to scaling. A blocking system scales in a really simple but kind of brute force way. More users? Okay, just add more threads. And that works for a little while. But it's a direct path to running out of resources. Eventually, you're just going to run out of memory. It's not a sustainable way to grow. But the reactive model? Oh, it's a totally different story. It scales so much more elegantly. Instead of throwing more threads at the problem, it just reuses the ones it already has more efficiently. And that means a small, fixed number of threads can handle thousands, even tens of thousands of connections without breaking a sweat. And this efficiency gives you some major real-world wins. You can see reactive systems are amazing at handling high traffic, they stay snappy and responsive even when they're getting hammered with requests, and they do it all while using way less memory. This is exactly why they are the go-to choice for modern APIs, streaming data, and microservices. So let's just bring it all home back to our simple analogy one last time. The phone call is blocking I/O, where your worker just waits. The WhatsApp message is non-blocking I/O, where your worker sends the request and moves on. When you think of it that way, it really is that simple. And that's what I want to leave you with. Think about the systems that you work on every day. Are they built like a phone call where everything gets stuck waiting? Or are they built like a WhatsApp message, firing off tasks and efficiently moving on to the next thing? Because the answer to that question could change everything about how you approach performance